Good day to you. This video is going to be about magnetic fields again, but this is the second video. So if you're watching this one, you have no idea what I'm talking about, then you need to go back and find the first one. So first of all, I'm just going to go through a few of the core questions which will pop up in this lesson. First one is, does the Earth's magnetic field hold things onto the ground? Firstly, there's a little reminder in there that planet Earth does have its own magnetic field because of the iron that we have at the centre of the Earth. And again, that leads me onto another reminder that we are not inside the Earth. Okay, you got rock and mantle and stuff and magma inside the Earth. Okay, we are on the Earth. We are literally on the surface of the Earth, not inside it. And obviously the Earth is not hollow. So does the Earth's magnetic field hold things onto the ground? No, it doesn't. It's not holding this spoon onto this table. It's not holding me onto my chair. It's not holding this paper onto the table. You know what's holding those objects down on the ground or on the table, etc., etc. And that is gravity. Okay, so that might seem like a simple question. Don't let it confuse you. It's just trying to trick you. The Earth's magnetic field does not hold things onto the ground. And then the next question is, does the Earth's magnetic field hold the atmosphere to the Earth? Again, the answer to that is no. That is gravity still. So yeah, don't think that the atmosphere is being held in place by the Earth's magnetic field. Magnetic field lines point in which direction? Actually, I'm going to go back to this diagram from before. Hopefully you remember it. And I'm going to say that this is north and this is south. That's what I'm deciding it's that. I could put the magnet on there, but then I don't know which way I was holding it on the paper before. So north and south. Now it's important that you know that the direction of the magnetic field goes from north to south. So away from north, but towards south. So if I were to draw arrows on here, which I think I asked you to do in this lesson anyway on your own diagrams, can you see how it's pointing away from north? I'm just going to keep going round, away from north. Away, away. This is the same line, but I'll just draw them around here as well. And you can see away from north is towards south. Towards south, towards south. There we go. Away from north, towards south. Away from north, towards south. Away from north, towards south. Okay, so that's something that you're just going to need to remember. From north to south. It's always pointing towards the South Pole. The next question is, what does it mean if the magnetic field lines are close together? And then the question after that is, where is the magnetic field the strongest? So those two questions are kind of one and the same really, because you can see that the magnetic field lines are closest together here at the poles. Look at this distance here, and this distance, and this distance, and this distance compared to up here. That's a lot bigger. This is even bigger. Not even bigger than that, I just mean even this gap here is bigger than the gaps over here. Again, that's quite a big gap, but you come over here and they're smaller again. So the magnetic field lines are closest at the poles, both North and South Pole, and that actually shows you how strong the magnetic field is. So the magnetic field is strongest at the poles. So here, the magnetic field is strongest, and here, but not here, which is not that surprising if you think about it. If I have my magnet and I'm picking up this this here, it doesn't really turn, okay, it does do it to the side, but it is actually, it's because I've got a really quite a powerful magnet compared to the ones we use at school, so that's not that helpful. But actually, maybe I can do it by how far away, let's just move this out, how far away before it picks it up. You can't really see that well because of the angle. How close do I have to get? That was maybe a centimetre or less from the paper. I'm hoping that this will pick it up closer. No, so that's really unhelpful. Again, if you've got a magnet at home, bar magnet, then you can test that out for yourself. But I'm sure you have seen before that most of the time you use a magnet, things get attached to the ends and not to the sides as much, because the magnetic field is strongest here, and the magnetic field lines are closest here, even though I can't see it with my eyes. But we did prove last lesson how you can actually observe the magnetic field, so using either iron filings or a compass, so that it looks like that. Okay, I hope that's helpful. Have a lovely day.